So in this video, we are going to talk about where the electrons are located in the atom. To this point, we know that the electrons are located somewhere outside of the nucleus, and it's usually described as an electron cloud. It is going to be incredibly important for you to know and understand where and how those electrons are located outside of the nucleus of the atom, because how those electrons are arranged has an enormous impact on the properties of those particular atoms, of those elements. And it's going to determine what sort of bonding those atoms, those elements undergo, and what sort of reactions those elements undergo. Okay, so when talking about where the electrons are located around that nucleus, we are first going to talk about energy levels or energy shells. And I tend to use energy levels more often than I do energy shells. Your instructor may focus or call them shells as opposed to levels, but they both mean exactly the same thing. So the first model that we had of exactly where these electrons are located is called the Bohr model of the atom. And don't worry about the name of that particular model, but it's sort of a planetary model for where those electrons are located. And so here, let's try a different color. Here is my nucleus. I've got a positive nucleus. And we have found that there are 7 shells, 3, 4, and you get the idea, right? I could go out to 7, but that each of these rings is a shell or an energy level, and there are 7 total. That lines up beautifully with the number of periods on the periodic table. Right, there are a total of 7 periods on that periodic table, and what we're going to find is those are going to correlate directly with the number of rings or number of shells around the nucleus of the atom. Now what's interesting is what we found is that Bohr model did not hold up for atoms that had lots and lots of electrons. It worked really nicely for hydrogen, but nothing larger than that. And so that leads us to the quantum mechanical model of the atom, or the quantum model. And what this model says is that inside of each energy level, we have sublevels or subshells. And there are 4 different types of subshells. There's an S subshell, which literally is a sphere. So think about it like a baseball or tennis ball. And that S can hold up to 2 electrons. We have P subshells or sublevels. These are sort of like a figure 8 shape or a dumbbell type of shape. A lot of times I have my students think about this like a peanut type shape. And those can hold up to 6 electrons. The d orbitals or d sublevels can hold up to 10 electrons, and the shape of these start to get very strange. And then the F shells or subshells can hold up to 14 electrons. Okay, so now what we're going to do is we're going to take that information that we learned on the previous slide, the fact that there are 7 energy levels, and there are S, P, D, and F subshells. And we're going to place this information on the periodic table. I highly recommend that you have a copy of your periodic table so that you can go ahead and write directly on this. I would also have colored pencils or markers or something so that you can label this as needed. All right, so the first thing I mentioned in the previous slide was the fact that we have 7 energy levels or 7 shells, and we have 7 periods. Now, that has been labeled for you on the left-hand side of your periodic table, right? Hydrogen's in period 1, lithium's in period 2, sodium's in period 3, all the way down to francium in period 7. I would go ahead and write these numbers on the other side as well. Just kind of helps to keep everything straight, right? So Helium is in period 1. Oh, that's terrible. 1. Try that again. 1, 2, 3, 4, 5, 6, and 7. Okay. So now that we have the periods labeled, I'm going to go through and show you where the S block is, the P block, D block, and F block. And what this is going to correlate to is what subshell is actively being filled in that for that particular element. All right, so my S block elements are going to be in the first 2 columns. So they are going to be right here. Right here. And notice I left a space next to hydrogen. So helium, even though it sits over here on the right-hand side of the periodic table, and it sits there because it does behave, it is a noble gas, and so it does behave, has very similar properties to the rest of the noble gases. When we're talking about its electronic structure, it actually is going to be in the S block. Okay. Now, so let's go ahead and label that. So red means that those are my S subshells, my S block. There are 2 blocks, right? And if I look at hydrogen and helium, that adds up to 2 spaces, 2 blocks. That corresponds to the number of electrons that that S subshell can hold. So 2 blocks equals 2 electrons. Okay. Talk about the P's next. So the P subshells, and the P subshells are located all the way over on the other side of the periodic table. Okay, so those are my P's. And remember that we said that the P's can hold 6 electrons. Well, if I count the number of blocks going across in that period, there are 6. That correlates to 6 electrons for the P's. And again, note that helium is truly in the S's, and I did not include helium in the P's. The next are going to be the D's, and this is where the transition metals are. So right in here, I really wish I could draw a little bit better. These are the D's. And if I go ahead and count across, I will have 10 blocks, 10 electrons. Now the last pieces, and we don't really deal with these very often, really if at all in this course, and that's these guys down here. These are referred to as the inner transition elements. These are your F block, and if I count up the number of spaces going across, there are 14 electrons. Okay, so this basically shows you exactly what we just did and what we just talked about in the previous slide, and having you write on your periodic table and put where the S blocks are, the P block, the D block, and the F block. Now, the one thing about this slide that this highlights is this number out in front of the block, right? So again, remember that helium over here really goes here. But you notice that going across that first row, that we're talking about the S block, and that is labeled with a 1 outside of the front of it. And if I go down to the second period, that is labeled with a 2. And it's labeled with a 2 for the S's, and it's also labeled with a 2 for the P's. That number out front lets us know what energy level we are in. So that number right here, that tells us about the energy level. And it lets us know which energy level we are in. It's followed by the subshell, so it tells you what energy level and subshell that particular of those electrons are in. One thing that I want to point out that is just a little bit odd, if we go down to period 4, so you'll notice that here we deal with 4s, and then we go to 3D, and then we go to 4P. I'm going to talk in a couple of slides from now exactly why that is, but for the moment I want you to think about the D block elements, and it's going to be the case going right for period 5. We go 5S, and then we go 4D. I want you to be thinking about the D block elements actually are going to be in a lower energy level or a previous energy level. So as we're filling up, we would fill up 3S, 3P, then 4S, and 3D. And same thing, 5S, then it goes to 4D, and then 5P. And again, we really are not going to deal much with the F block elements. Those guys are down here, and they really go right here, right? They were actually moved and put down on the bottom to make the elements fit on a regular piece of paper. But if I'm going across, right, in period, so 4F is really in period 6, and 5F is really in period 7. And as I'm going across, right, S is 6. F is actually, for going across period 6, F is actually 4. So for the F block, they are 2 below, or 2 previous energy levels but before the period that you're actually in, if that makes sense. But again, we're not really going to deal much with those F block elements. And I promise, as we start to practice with these, I promise I will do some D block elements so that you can see exactly how to go about filling that up. Okay, so here's a bit of information that I wanted to make sure that you had and that you understood. So basically, I'm taking this information from the previous slide, I'm just consolidating it right here. Very important for you to know that in energy level number 1, right, so period number 1 only has an S block, only has S subshells. For energy level number 2, or period 2, and again, think about the number that goes in front of the subshell. For energy level number 2, I only have S's and P's. I have an S block, or I have S subshells and P subshells. Remember that the S subshell holds 2 electrons, the P subshell holds 6. So for that full energy level, I have a total of 8 electrons. For energy level 3, I have S, P, and D. S are 2 electrons, P are 6 electrons, D are 10 electrons. So that gives us a total of 18 electrons. And then for energy levels 4 and up, we have S, P, D, and F. S is 2, P is 6, D is 10, F is 14. Add those all together, and that gives you a total of 32 electrons. Okay, so now that we have some of the background information, we can go ahead and start working on our electron configuration. So there are 2 things I want you to be thinking about when doing this electron configuration. Number 1, this is essentially assigning an address to the electrons. We're telling everybody where, what energy level, and what subshell those electrons are existing in. The other thing I want you to be thinking about is we're going to move across the periodic table sort of like it's a board game. And I'll explain that as we do some examples. So the first one we're going to take a look at is we are going to take a look at hydrogen. Now hydrogen sits right here. Hydrogen has 1 electron. So we need to tell everybody where that electron exists. Well, that electron sits in the first energy level, right? So it sits in energy level 1. That electron, we've moved 1 space into the S block. So I have that electron sitting in the S block, and then I'm going to, as a superscript, that's a terrible one. Let's try that again. I'm going to have a 1 superscript here, and that just tells everyone that there's 1 electron in that S energy, or that S subshell in energy level number 1. So we have the energy level, we have the subshell, and then we have the number of electrons in that subshell. Okay, so far we've taken a look at the electron configuration for hydrogen. And again, we're talking about where those electrons exist around the nucleus of the atom. And again, you want to think about these as sort of like an address for each of the electrons that exist in the atom. So we're going to do a few more examples, and we'll do some that are a little bit more complicated than hydrogen. And so the first one we're going to take a look at is helium. And like I said in the previous slide, I want you to look at the periodic table as though you're moving across a board game, sort of like a Candyland or something like that, just no chutes and ladders. And keep in mind the blocks, right? Where the S block is, where the P block is, the D block and the F block. And again, keeping in mind what period you're actually in. So before we get started on this, I am going to go ahead and just draw my periods, or write out my periods on here. And remember, it would be awesome if I could count, right? Remember, these correlate to the energy level. And also keep in mind our blocks. These first two are our S block. Remember that helium really should go here. Our P blocks, our P block is right in here. And our D block is right in here. And then our F block is down here. Okay. So for helium, I'm going to go ahead and go across, right? And I'm going all the way across that first energy level. Helium is in an S block. It's got 2 electrons, right? So we know that helium has 2 electrons. And so both of those electrons are going to exist in that first energy level in the S subshell, and there are 2 electrons there. So my configuration for helium is 1s2. Okay, I'm going to take a look at lithium next. Now lithium is element number 3, so it sits right here. We know that lithium has 3 electrons, and when I go to figure out my configuration, again, I'm going to use this like I would a game board, and you always start from the beginning, right? So I'm always going to start in energy level number 1. That has to get completely filled up first. So I am going to go completely across energy level number 1. And so filling that up gives me 1s2. Keeping in mind, and I would definitely write this, that energy level now is completely full. Once I put 2 electrons into that first energy level, it is full. And now I am 1 space into the S block in period 2. And so that means my configuration here is 2s1. So my complete configuration for lithium is 1s2, 2s1. The last one I want to take a look at is oxygen. Let's get rid of these arrows here so we don't have too much of a mess. Okay, so oxygen is right here. And oxygen is element number 8. So I know that I have 8 electrons in oxygen. And one thing I forgot to mention, you can double check yourself to make sure the configuration is correct by adding up how many electrons you have. So for lithium, I had 2 electrons in 1s, 1 electron in 2s, and if I add those together, that gives me 3 electrons, which matches exactly how many electrons are in lithium. Okay, So we're looking at oxygen and looking to fill or figure out the electron configuration for oxygen. So like I mentioned before, always start at the beginning. So I'm going to go completely across and fill up 1s. And so I've gone through to the 2s blocks, so 1s2. Now I'm in period 2, and I'm going to go straight across the s block. So I've completely filled up the s block, that is 2s2. And now I am 4 spaces into the p block, still in energy level 2. And so that gives me 2p4. So my complete configuration for oxygen is 1s2, 2s2, 2p4. And again, if I wanted to just double check and make sure that I have the correct number of electrons, I have 2 plus 2 plus 4. If I add all of those together, that gives me 8 electrons. Also want to point out that 1s is completely full. That first energy level is completely full. This will become important in a little bit. All right, so as I mentioned before, we're going to talk about the D subshells and why they do that funny thing, right? So we don't see them until we get to period 4. And so when we're going across period 4, we would fill up 4s, then 3d, and then go back to 4 and fill up the P. So one thing I did not talk about previously was that the energy level, right? So the period or the energy level, those larger numbers that come out front, talk about how far away the electron is from the nucleus. So energy level 1 would be closest to the nucleus, energy level 2 is further away, energy level 3 is further away, and on and on. So it takes more energy to fill up those higher energy levels. So it's easier to put electrons in energy level number 1, but harder to put them in energy level number 2, and even harder to put them in energy level 3. This table down here at the bottom of this slide talks about that energy and the amount of energy required to put those electrons into those energy levels and subshells. So it ends up being much easier to put electrons into smaller subshells like S, and much harder, requiring more energy, to put the electrons in the Ds, which are 10 electrons, or the Fs, which are 14. And so this chart down here in the bottom left-hand corner shows the energy, the amount of energy it required to put those electrons in. And honestly, I would not memorize this. Use this as a tool if this helps you to see why this is set up the way it is, but at no means do you have to memorize this at all. So energy level 1, or 1s, has the absolute lowest energy. Next is 2s. And then 2p, which kind of correlates with everything we've been doing right along with the periodic table, right? Next in energy is 3s, and then 3p. And then we get to some funny stuff here with the 4s, 3d, and 4p. So 4s is right here. It turns out that it's going to be much easier to fill up 4s because it's smaller subshell than it is to fill up 3D. So 4s has a lower energy, then 3D, and then we go back to filling up 4p. So if this helps you, then use this. If it doesn't, and you're better off focusing on the periodic table, then go ahead and do that. All right, so I want to do an example so that you can see how we go through the D blocks, or how we incorporate the D block when we are doing configuration. All right, so what I want to do here is I want to talk about chromium. So we are going to do the electron configuration for chromium. And so chromium here. And again, I want to start right from the beginning, right? I'm going to start in energy level 1. So I'm going to go all the way across and completely fill that up. So it is 1s2. Then I'm going to go to the next energy level or the next period. I'm going across the S block. So that takes me to 2s2. And all the way across the P block. And so that takes me to 2p6. Next, I am going to go down to energy level 3, period 3. I'm going to go straight through the S's, so that's 3s2. And then I'm going to go straight through the P's, so 3p6. Now I'm going to go down to period 4, energy level 4. I'm going straight through 4s. Right, so those two blocks, so that's 4s2. And now I get myself to chromium, and it is 1, 2, 3, 4 blocks into the Ds. And so this will be 3d4. You do definitely want to make sure that you write it out in the order that you went and filled it in. So I would absolutely write out 4s2 first and then 3d4. That would be the correct way to write this out. You are less likely to make a mistake if you do that. Don't go back and try to put the D, don't do that. Don't try to put the D in front of the S. That's a bad idea. You're more likely to make a mistake that way if you do that. So go exactly the order that you went to fill that up. Okay, so here we're going to talk about the shorthand electron configuration. You are also going to potentially see this or hear this as the noble gas configuration or the noble gas notation. So the two elements that we're going to do the shorthand electron configuration for are going to be selenium and yttrium. Now, where is selenium? Here is selenium right here. Now, the reason why we are going to focus on this shorthand, and I'm going to actually do the longhand for selenium and then show you how to do the shorthand. If you were to do the configuration for something like lead, which sits right here at number 82, it would be really long to start with 1s2, 2s2, right? That would take you an awfully long time and a lot of ink to write that out. And in general, we're more concerned with the electrons that exist on the outside of the configuration. We'll talk about specifically what those are and what those tell us. So let's go ahead and we'll write out the full configuration for selenium. So again, we want to start all the way at the beginning, right? So we are going to go through 1s2. And then we're going to go through 2s. And then we're going to go through 2p. And then we're going to go through 3s. And then go through 3p. And then here we are, we're going to go through 4, oh, I forgot the 6, so 3p6. And we go through 4s. And we go through the D block, and remember that is 3D. And there are 10 electrons. And then we are 1, 2, 3, 4 spaces into the P. And that is going to be 4p6. That's not so bad, right? Or so horrible. But it would certainly be nice to be able to shorten this down so that there's a little bit less writing and so that we can focus our attention really where we want it to be. Now, remember in the previous slide, I had said, I didn't really make a big deal out of it, but I said these are full energy levels. What we have right here is the 1s, the 2s, or the energy level 1, energy level 2, energy level 3. Now you're going to argue with me on this because I've got 3d10. But that's full, right? And if I were to do the configuration for argon, I would say 1s2. 1s2. 2s2. 2p6. 3s2. 3p6. So rather than writing all of that out, rather than writing out 1s2, 2s2, 2p6, 3s2, 3p6, especially considering that those are full shells, and what we will find is that these full shells do not interact. They do not, those electrons, you want to think about them almost like being locked in place. Those electrons are never going to be involved in reactions or bonding. It's always going to be the electrons that are on the outside part that are going to be involved in that. So I'm just going to cross off my yttrium to give me a little bit more space. my shorthand noble gas configuration is going to be the following. I'm going to write argon in brackets, and that argon in brackets represents all of this. So my configuration is going to be argon in brackets followed by 4s2, 3d10, 4p6. Now in general, what I tell students to do, and we'll do yttrium next, is I tell students, and let me go ahead and erase everything that I have on the periodic table here. There we go. So we were interested in selenium. So what I tell students to do is I tell students to go ahead and look for the noble gas that ends the period before the element that you're working on is located in. So selenium is located in period 4. So I'm going to look to the previous period and see what noble gas completes that period. In this case, it's argon. So I would write that noble gas in brackets, and that represents the configuration up to that point. And then I would finish the configuration by focusing on the period that that element sits in. So let's do yttrium as an example. And I'll show you how this works. All right, so yttrium, let's write him over here, sits in period number 5. So what I want to do is I want to take a look at period, so if I'm in period 5, I want to take a look at the noble gas that ends period 4. And that is going to be krypton. So what I'm going to do here then is I'm going to write krypton in brackets. And what that is going to represent for me is the entire electron configuration up to krypton. So if I were to write that whole thing out, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. You can practice that by writing that out. But then I'm only interested in what's going on here, right? So I've written krypton in brackets, and then I go across 5s, so 5s2, and then I am one space into the d's, and remember the d's are one below the period that you're in, so this would be 4d, and I'm one space in, so it would be 4d1. There's a lot of practice with this in your guided practice. Make sure you do this and make sure you bring your questions to class.